Hi everyone, welcome to another episode of Mr. Carlson's Lab. I've got another great video for you today. Today we're going to scratch build a power supply with those junk box parts that we found in the previous video. There's lots of great power supply building information in here, right down to putting wrinkle coat paint on chassis and making it look just like it did from the factory. So lots of building to do. Let's get started. In the previous video, we put together a power supply from junk box parts here on the bench, using alligator clips to connect tubes to transformers, and rectifier just tacked into place with filtering and a filter reactor. This was all done in real time. So if you're interested in seeing the video that led up to this, I'll put that link just below the video's description under the Show More tab. You can click on that, and that's the previous video that led up to this. In fact, I'll put two other links there as well. I have an electronics course on Patreon, and it's not like I'm asking for a free coffee or anything. You're getting an electronics course, and there's 200 videos there that you don't see here on YouTube, along with all of my inventions and plans. So if you want to build a capacitor tester, or if you want to build the ultra probe, all those plans are there with schematics and diagrams and layouts and all of that kind of stuff. So it's a great place to be. There's a lot of people there. Definitely feel free to check that out. And remember that that place fuels projects like this. All right, the amount of time it takes to do what you're going to see in this video is absolutely astronomical, and you'll see that if you watch this video all the way through. You'll see how incredibly crazy it is to do a project like this. We're going to paint transformers. I'll show you how wrinkle coat works in this video. So if you want to make your transformers look like they did when they rolled out of the factory in the 40s and the 50s by using wrinkle coat paint, I'll show you how that all works. And we're going to repaint this. Even the chassis that we're going to choose is going to be wrinkle coated. And we're going to put tubes on it. I'll drill all the holes. I'll show you the entire process as we take what you see on the bench here, which looks like an absolute rat's nest, and it's going to be put into a very nice box. So whether you build vacuum tube amplifiers, whether you build modern projects, there'll be a lot of information in this video for you how to actually build something like this, or something very close to this, even modern. A lot of what you're going to see in this video is also very applicable for any type of a modern build. So I'll put the link to Patreon down there as well. If you feel like just supporting this place, it's absolutely fine. Again, that support fuels projects like this. And I'll also put a link to a forum under there. I have a free electronics forum that you can take part in. There's no advertising on it. I'm paying for the whole deal. So all the serving, all the, the website, everything, I'm paying for everything on that. And that's also free. You can join that. There's a lot of people there now. I launched it a while back, and I haven't really talked about it. Just like I haven't talked about the Ultra Probe. That's a project that I released quite a few months back on Patreon. I haven't really done any demonstrations on any of this stuff. So you'll see people with their builds there as well. It's also a great place to be. So, no pressure. Feel free to join if you want and just watch or whatever. But yeah, it's a great place to be. Lots of really good people and a lot of respectable people on that forum. I like to keep everything very respectable on this channel. And, of course, everywhere on Patreon and in that forum, everything is very family friendly. Of course, this is all about electronics. There's no ranting and raving. There's no nothing on this channel. You came here for electronics. You're going to get electronics. And, that's just what this channel's about, and that's what I'm about as well. So anyways, with all of that out of the way, I'm going to take all of this apart. Oh, and also one other thing here, I've also enabled super thanks here on the channel. So if you click on the little dots underneath the video there, you'll see super thanks if you feel like putting anything towards this project or the future parts of this Grand Receiver Restoration series. Feel free to do whatever. It's completely up to you. Anyways, anything is appreciated, right? Because this all goes right back into this channel here. And when I mean all, so it's all going into this to keep this channel going and to keep everything happening here on YouTube and all of that stuff, keep the website going and keep everything going. So anyways, back to this. I'm going to take all of this apart. So I have to take all of this apart now. And what I'm going to do is I'm going to show you a trick to sizing the transformers onto a chassis so you can drill nice and straight. It's a very, very simple process. And we'll move on from there. I'll show you how to paint this wrinkle coat on and how well it works. And painting the core, there's a couple of tricks with this in order to get a very nice looking core. And drilling tube sockets and holes. We'll get all of that happening. Look at the chassis. chassis on here next, and I'll start filling you in on my entire thought process in this, and then we'll move out to the shop and start drilling and painting and grinding and whatever, all the stuff that we need to do, even some garnet blasting on the transformers and stuff. Not a necessary process, but I just like to do that. It just preps the surface nicer. So let's get started. The very first thing that we need to address here is get these things sitting on the chassis so that we can drop the mounting holes. After that, we need to take the bells off of these. The bells are the covers on each side of the transformer. Get them prepped and painted because they have to sit for a while. And it's the same with the chassis. We want to get all the drilling done first, and then everything can sit. By the way, this video is in 4K as well, so if you want to watch this in 4K, just below the video is a gear icon. Click the gear icon and select 4K. This is the box that I am going to be using, the project box. It's a Hammond 1590F. I have many of these types of boxes around. When I design things, projects, and release them on Patreon, I'll use different variation sizes of this particular box because they're very well shielded. So very good for low noise. And also they drill and machine very easily. So the little bit of extra money that you pay for a nice cast box like this, you pretty much gain back in ease of working. So fantastic boxes to use. So that's what I'm going to use for this one here. And I think everything will fit just perfectly. It's not too big, it's not too small. It's just, just right. So the first thing that I want to do is size up the transformers here. So I'll sit the transformer on the actual chassis. Now here's something to think about if you're going to build an audio amplifier or something like this. A lot of people will mount the power transformer like this, and for look's sake, they'll mount the audio transformer like this. Well, what's this going to do? Well, you're going to get hum in your audio transformer because the cores are in line with each other. So what you need to do with a transformer, it doesn't look as pretty as having everything in alignment like this, the cores like this, but the audio transformer has to be 90 degrees to that one. So you have to do this in any type of an audio build where you have a core like this, and I'm going to do that as well with this filter reactor right here. It's a very easy test for you to do. If you have a power transformer, all the leads are insulated, and you just power the transformer up with no load and have it sit on a chassis, you can take your audio transformer, leave the primary completely disconnected, nothing's attached to it. Attach a speaker to the secondary load, so say it's an 8 ohm transformer, attach an 8 ohm speaker to it and set the transformer next to the power transformer, and then just power this one up and see what happens. What are you going to hear? Well, it's going to hum. You'll hear a hum in the speaker. So if you listen to the speaker and you take the transformer, you do this, it'll be That's how pronounced it is. You'll find that they couple very well like this. So you want this 90 degrees like so, and that really cuts down. Sometimes you'll even find that the best point to actually get rid of all the hum is not on a 90, it's actually a little off. So sometimes they hum, even have a lower hum when they're like so. So that's something that has to be experimented with if you're going to design an audio amplifier from scratch. So always keep that in mind. That's a real catch for new amplifier builders. And believe it or not, some experienced one too. So, second thing we need to think about when we're mounting this is we don't want the transformer to hang over the edge of the chassis like this, and we don't want it too close to the edge. So we want it in this particular transformer, keep it even, maybe something like a 1/4 inch or something like that. It's not too crucial, maybe just about 1 centimeter or something like that. In from the edge, and that way we don't have anything hanging over, and it makes the build look that much cleaner. And it's the same with the actual reactor as well. You want it in from the edge just a little bit. You also have to keep in mind that when you're dealing with these boxes, when you open this box, this is a wall here, and so this wall runs down, so you can't drill too close to the wall. If you try to drill close to the edge, you'll drill down the wall. So you need to be back from the wall a little bit. In the corners of these boxes are the extrusions to put the screws in. There will be extrusions in here as well, and extrusions here, so you have to be careful that you miss those extrusions. Some other mistakes that you'll make with a box like this, so I'll just open this up here. Brand new box, as you can see, never been opened. So just waiting. It's got a piece of tape on it from Hammond maybe. And like so. So you can see when we open the actual box up, you can see the extrusions in here. So you got to be careful that you don't drill too close to these extrusions, so things have to be away from them as well. Again, you know, half a centimeter, you know, about a centimeter or something away from the ends is probably going to be okay. You can see this is a pretty large extrusion down here, and it goes right to the top. And of course, that's, you know, that'll mess with your build. So what I'll do here is I will measure some things up. Again, this all has to be done before any prep work is done. You want a uniform surface when you put the paint on, because you want the paint to look just about as flawless as possible, right? So I'll drop some holes here. I'll just lay these on here and mark some holes, make some center punches, and we'll head on out to the shop. This will be like so. We'll head on out to the shop and start drilling this thing up. This is about roughly where the transformers will sit. Now there'll be a little bit of movement because when we mark the screws down here, we want to go for the center of this little area here. We don't want to put the screw here or here. We want it in the center, and that way we can move the transformer a bit. We also want to mark the edges here. So you can take a felt. If you're going to sand the chassis after, it's very easy to get a felt off. You can take a felt and just go around the corner here like this and give yourself a corner. And then the same thing with the other side, give yourself a corner, draw a straight line, because when you drill a hole in the chassis for these wires, you don't want the hole to be past the end of the bell. So you have to bring the hole saw back so that the edge of the hole saw isn't near this. That way the wires will be completely contained and it won't make a very sloppy looking job. These are all little catches that if you don't pay attention to, they'll get you in the build, and you'll ruin an actual project box. So same thing with this. This here doesn't have the area to slide the actual transformer around, so basically just a single dot in each hole. And then again, mark the front side of the actual reactor here, so put a line across this, and then you know when you drill the hole saw's edge will have to be, you know, in here, so that way the wires and the hole doesn't protrude out here. Again, you also have to keep in mind that there is a ledge inside the box that's to about here, because the wall is about that thick, right? So this is away from the corner and it's not going to hit any of the extrusions, so that should be a nice clean job doing it just like so. So I'll get this marked and we'll get those holes drilled. The first holes are just pilot holes, so they're much smaller than the actual drilled holes. The reason being is the tip of the drill bit will fit into the center punch mark and it won't wander. That's the reason I pre-drill with a smaller bit. You'll also notice on the bottom of the box, the bottom is on. Through the entire drilling process, the bottom of the box is on. That way if I clamp it or anything, the walls aren't weak and I don't risk damaging the actual box. So the first thing I'll do is I will center this like so, having my hand on the drill press here, and just see if I can line it up first, no problems. Turn this on and give it a touch and it's perfectly aligned. And there's no wandering. Then I shut the drill press off again, and then I move over and I'll do this again. So I'll just pretty much make sure that this falls right into the center punch, right, like so. And you can even hold the drill bit there. A lot of the times I'll do that. I'll just keep a bit of pressure on this, turn the drill press on. This is really only valid for smaller drill bits. And, you know, of course, clamp your work if needed, just like so. And you'll drill right in the center of your center punch every time. It won't wander from that, because, you know, there is a chance that you can even wander out of your little center punch mark. Now that all the holes are pre-drilled, I have a 964 drill bit in here right now, and I'm drilling it to 964 because I'm going to tap the holes here so I can just thread a screw right in. So this will work with an 832 screw, and I have the tap right here. So I'll just tap this, and then I don't have to run a nut on the other side, and it just makes things a whole lot easier. So it'll just guide its way. You can see how it just kind of pulls the box in. Same with this back here. See how it just centers the box on its own now? Just makes alignment all that much easier. And now that this is done, this is very soft stuff. So tapping this is very easy. Basically, just put this on top and you just give it a bunch of twists. I can feel it, it's just cutting perfect without even any oil or anything. Just make sure that I'm cutting this straight up and down. And look at it from this side. And that's pretty good. And it's thick enough that it'll hold those transformers just fine, especially four screws through the top. So that's it for that. And then just back this out. Now I don't need to use a nut on the other side. So an 832 screw will fit right into that threaded hole, and I can mount the transformer. So of course, before I do that, I need to drill a hole for the wires. So that's quite a large drill, and that's what we will tackle next. After that, it's the tube sockets, a socket in the back to run an umbilical cord to the radio, and in the front side here, we'll also need to put a line cord into this. The radio itself will switch this power supply on and off. And I think I'll put a jewel light in the front, so we'll look around for a junk piece of equipment that we can harvest a jewel light out of, and yeah, it'll have a nice, kind of like a ruby red lamp in the front here. I don't know whether I should have it off to the side or in the center. I'll think about it, and I guess when we come to that point, we come to that point. All right, on to the next step. I think a 7/8 hole saw should be just fine for the wires for the power transformer. So again, we want to stay away from that line. We want to be back from that line a ways. Then it doesn't matter if the core of the transformer is here and say it's over the hole a little bit, that's fine. We just want ample enough room for the wires, and we don't want it to be too tight around the wires. And I think 5/8 should be fine for the little reactor. 5/8 is actually relatively big because there's only 2 wires that come out, but I don't want either hole tight on the wires. I want the wires nice and loose. And of course, after the holes are drilled, I will sand the hole to make the edges nice and smooth, so that when the wires come through, there's no risk of actually cutting them. So what I'll do is I'll measure between, get this one off here first, measure between these two, and it's about 6 centimeters. So 3 is about the center. So if I move this out of the way, yeah, from about center to center. So 3 is about the center. So we know that that's the middle right there. So we know that, at least that's the middle for the actual, this isn't really crucial because wires come out both sides of the transformer, right? So the fact that they are actually coming out both sides of the transformer, they both basically funnel out of that hole. So we just want to get it as close to center as possible. Now this whole thing is going to be sanded. I could use a square for this, but eyeballing this is close enough. Again, this really is not that crucial. So you can put that there. And let's see what it is for this one here. Well, from about edge to edge, we could say 5, so 2.5 for this one. So that's about the center right there. And again, an eyeball is close enough. My eyes are pretty straight most of the time. So, and basically at this point here, we want to know about the center of the actual drill itself, and that would be right about here. So right about there would be fine. And you can see, just size it up. Oh yeah, lots of room. And then for this one here, we want it a ways away from the front again, so right about there. And I think this one honestly is going to be centered right between the 2 screw holes here. So I'll put that right there, drop that down. Well, that is, it's a little close to the edge, so we'll call it back here. And I'll draw a little arrow just pointing to it so I know I'm not going to change that. Double check this one here. Yes, there's lots of clearance there. So now I will drill the 2 holes here and we'll have the holes for the wires all done. Perfect. Lots of room. All right, I used a large drill bit just to basically deburr the hole. So I just pulled a large drill bit out of this case and just ran it around in here just by hand. Just cleaned that out. So I'll probably end up sanding it as well. But right now, I just want to size it up and see if these transformers are going to go through. So I got the bottom off this thing. And let's see. Looks pretty good. So it should go through with relative ease. All these wires are all bent and everything from me soldering them earlier, so I'll straighten them up a bit. There's a lot of added width as well because there's that tape from the old system that I haven't taken off yet. All right, on that backwards like so. And looks pretty good to me. Yep, looks very good. So the holes will be about centered. So that one's there. And of course we have our other one here. Take a look at the holes there. Oh yeah, that's yep, absolutely great. Okay, I think this is going to look fantastic. So the 2 regulators on each side and the rectifier in the middle. Now it's very important to take note of the socket and where the index is, because if I was just to drill, say, the socket like this or something like this, and then, you know, mount everything and then not realize, oh, hey, wait a minute, the tube sits this way, right? And if it sits that way, it doesn't look so good from the front. So what I mean is a lot of these tube sockets, you can actually take this ring off like so. I can get the ring off to show you. It's kind of jammed on here. It's gone around the other side. There we go. So you can take the ring off and you can put the ring on like so. You can see the index here. Or you can put the ring on like so. So you can move this socket however you want. And of course, because I want the index facing back, because this way we get the best view of the tube, what I would want to do is make sure that this ring is on like so. And the reason that I want the screws off to the side like this is when I draw a line across here to drill the holes, I can just, since the line is already there, I can measure, you know, out from the center of the hole and make the 2 little mounting tab holes on each side of the center. So that's what I'll end up doing. So I think that looks fantastic just the way it is, doesn't it? So you move the camera just a touch. I don't want to move the box because if I move the box, the tubes are going to fall over. So hopefully you can see that. And then this here would be about centered there. And that's how it would look. I've got everything all measured up and some pilot holes drilled here. So the size of the hole saw I'm using is 1 1/16. So it's slightly bigger than the diameter of the rim on the top here, just slightly bigger. So that should look pretty good in there. So not too big, not too small. A little bit of wiggle room, I guess you could say. So let's drill some holes. Looks pretty good. The trick is to go nice and slow. You'll notice that it looks like it's wandering and all that, but some of these blades I find on all of these things are out a little further than the others, which makes it look like it's wandering. Yeah, when you're driving it through the first time, you can actually see this moving just a little bit until I put my hand on it, but what are you gonna do? The bit itself, I've tried about 3 or 4 bits in 3 or 4 different holders. This is true, the actual chuck and everything is true, but for some reason, these bits fit rather loose into these hole saws. You know, of course, they're not made to be crazy accurate, right? So they fit a little bit loose in here. So when you tighten it down, it kind of puts the bit off center just a touch. Again, what are you gonna do? So drop this one on top. That is gonna be just perfect. And then of course, with the paint on here, the crinkle coat and everything, that'll give just enough room. That'll look really, really good. So I'll do the last one here. What I'll do is I'll just move this over like so, and then I can get a little bit better hold on this. There we go. That's looking pretty good. Now, another trick is, so I want to make sure that these mounting tabs are about even on each side. Here's the thing. I won't pre-drill these holes until after I've drilled this hole, just in case something wanders or moves, so that I don't have a screw that's, you know, way out in the middle of nowhere. So what I'll do now, put this on here like so, without getting my gloves caught. Doesn't really matter as long as it sits on there. And I pre-measured this, put a bunch of scuffs on there from the original pilot hole, and it's looking pretty good. So they're about right in line with where they need to be, and they're even on each side. So the trick for that is, this here will move around in the hole just a little bit, right? Because the hole is just slightly bigger than the actual rim of the tube socket, right? So I do this before, and really what you do is you measure from the center hole. So you measure from the center hole, so you mount this on here, and then you measure out, you know, from the center hole, and then what I do is I tighten the actual caliper. This isn't the actual measurement here, but you tighten the caliper, and then I just go scratch and scratch on each side, and that gives me perfect alignment on each side, and that's from the pilot hole, because that goes from this side. It's bracing itself on one side of the hole here, and you go scratch, and then here, and you go scratch, and then you get 2 even scratches on each side,
and then you can drill those out, and then you have nice even holes on either side. So what I'll do is I'll drill those out now and get those ready for the screws, and we'll move on to the next step. Again, a 964 drill bit for the screw I'm going to use. I'm not tapping these, but it'll work very well with the size of the screw. The screw will go right through those holes. The mounting brackets for the tube sockets mount on the bottom side, so I have to use a screw and a nut. And this stuff is so nice to work with. This stuff is so incredibly nice to work with, right? It just, you know, it drills so nice. All right, let's see how we did. So here is a tube socket. So that'll be mounted in the bottom like so. So those are the mounting holes right there. As you can see, there's a little bit of movement on the top, so I can center everything. I'll just try and center it here because I don't have any screws to hold anything centered. Put my finger on there, you can kind of see. Right about there. So no problems, looks good. And if we come take a look from the top, so it'll be roughly centered about there. And that gives us enough room for our thick layer of wrinkle paint. And there you go, that's what it's gonna look like. So that's perfect. You can see there's just a little bit of room around the top of the tube socket there, and that'll work out very well with the paint so nothing gets too tight. So the tube sockets are a success. So now there's going to have to be an umbilical cord from the back side of this. So I'm going to have to drill a hole in the center, and there will be another tube socket just like this in the center of the back here. And then there'll be a smaller hole with a grommet for a line cord. So the line cord will run into this unit as well. And then there needs to be, of course, there will have to be some form of a jewel lamp on the front. It should be red. I would definitely think that would look good red. So a nice bright jewel light with maybe a 47 incandescent bulb behind it, because again, this has to be built like it was built in the 40s, right? So that's looking pretty good so far. So I will get everything measured up here, and I'll tell you about that process as well. I went digging through my parts bin, and I found an authentic 1940s style jewel lamp. So you can see how the light is catching it there. Looks really nice. What I'll do is I'll grab a flashlight and shine it through the backside. Doesn't that look nice? So real authentic 40s style red jewel light will be on the front of this, so this is going to look really nice. I figure I should mount it in the center, so what I'll do is I'll measure from the top corner to the bottom cover corner. So something to remember when you're working with these boxes, if the bottom cover isn't on and then you measure to the edge here and you don't take the bottom cover into consideration here, right to the bottom here, it'll look off center when you put it all back together. Don't ask me how I know this. So from there to here, roughly, there to there, and then just draw a line. And it'll be the same for the tube socket on the back side. That'll be the that'll run to the umbilical cord. Here to here. And that'll look nice and centered now. The chassis is ready to go into the sandblaster. I actually have garnet in it, and it's about a medium garnet. So a few things just before I actually put this in. Things to note is you'll see I've put some screws in on the bottom side, and they're not really threaded through the top. That's just to protect the holes that I've threaded in this chassis. So I really don't want to hit them with garnet and damage the threads. It'll probably be okay without it, but you know, just an extra little step of precaution. All the holes are drilled. You'll notice that I mounted the tube socket off to one side because of this stand in the middle. You'll notice on the front side, the jewel light would only look good. Hopefully you can see that. The jewel light would only look good in the center of the actual unit. So this took a little bit of grinding here, so I had to drill right through this post and then grind the rest of it out from the inside. Other than that, it was pretty straightforward. All the holes are drilled. So it'll go directly into this, and then I won't touch it after that. I'm not gonna sand it or anything. All I do is I spray brake clean on this just to clean any grease or any oil off of it. And then I take compressed air and blow it dry so I don't get any towel fuzz or anything on it. And it'll be painted directly after that. And I'll talk about the painting process here in just a moment. So let's get this thing garnet blasted. I'm ready to start spraying this with the Wrinkle Coat paint. First of all, you'll see that there's a little booth here that I'm using. I never use one of these things. In fact, I've never used this one here. The only reason I have this little booth here is because I have a camera sitting right here and I can't have the overspray settle on the lens, so it'll pull that overspray into here. So the only reason I purchased this thing is just so I could show you how this Wrinkle Coat paint works. Normally, I'll have this thing sitting on a piece of cardboard with a 2x4 under it and I'll just walk around it and spray it, all right? It's really that simple. Now, some of the things that you want to keep in mind when you're spraying this little box right here is you don't want any lint on it to begin with. So try not to towel dry it or anything like that. What I do is I hose this down with brake cleaner, and then I'll use some compressed air, and then I'll use a heat gun to heat the chassis up a little bit to make sure all of the brake clean is evaporated out of the chassis, because you don't want any of that sitting on here, because paint and brake cleaner don't play nice with each other, right? So you want everything nice and dry. Now, before I even get going, I have a few things set up already. First of all, the heat gun, because I'll use the heat gun between every coat. So I usually put 3 coats on. You can put 4 on if you like. You can follow the instructions on the can that I'm about to show you here in just a moment. Follow the instructions on that can and you get very, very good results. So if you get any shiny spots or anything like that, you can give it a little bit more and heat it with a heat gun again, and you're usually very good to go. So the heat gun is here, it's ready. I have this little pan here, and the reason I have the pan here is because once I'm done with this, I'm gonna put this into an oven and let it sit there for about 45 minutes to an hour at 200 degrees Fahrenheit. So it'll just sit there and basically cure in there. And once that's done, I'll take it out of the oven and of course let it sit for about another day or two, just to make sure everything is nice and rock solid before I go about putting tube sockets in and transformers on there and things like that. So that's what this pan is here for. I have a piece of almost like thread rod. This is actually one of the thread rods that hold the bells on a transformer, go figure. So I just picked this out of my bin. What I'll do in order to lift this up without hurting the paint is I'll thread this into one of these holes while the paint is soft, and then I'll just lift this off of here, and then I'll put this onto that pan. This is nothing more than something to hold this up while I'm spraying it, and this little booth here came with a fancy little Lazy Susan, so hey, why not use it? So so there you go. So, and that's pretty much everything that's gonna happen here. So what I'll do is I'll grab the can of paint and I'll I'll get painting and I'll share that process with you. The Wrinkle paint that I use is this stuff right here. Now, it works fantastic and gives a very, very nice wrinkle. Follow the directions on the can. You really can't go wrong. It works very, very well. Now, I have to tell you though, prepping the surface is kind of important. So you definitely want to make sure that the surface is prepped okay. And again, that's all on the can. Make sure you shake this very well, you know, for the allotted amount of time. This has already been shaken, but it's been sitting for just a few moments. So I'll just give it a quick shake again here and get everything started here. So I'll turn on the little booth here, open this up. I have a scrap piece of paper over here that I can just spray this on a few times just to clean the nozzle, because I've used this can before. So what I'll do is I will put this down and just preheat this a little bit, just warm it up. Again, I'm wearing these nitrile gloves so that I don't get any grease on it. You know, it doesn't have to be very warm, just up to room temp. So let's move this out of the way. Give this a few quick little blasts. And here we go. Now keep in mind, you want this pretty heavy on each coat. They do a pretty good job of this stuff to stop it from running. Some paints you can spray like this and they'll just start running. So this stuff is really good. And if the surface is warm, there is a lot less chance of this actually running. You got to remember that if you do make a mistake, it's not a big deal. All you do is just wipe it down with acetone or lacquer thinner or something like that, and start over again. I've even soaked some of these chassis in a bucket of this stuff just to get rid of the last paint job. So now what I'll do is I'll give this a heat gun. And you really don't have to worry about too much fine dust with this. Even if you do get a bit of fine dust in it, it's not a big deal. Remember, it's wrinkle coat. And it's, you know, not a big deal. So you really won't see it in the end at all. All right, I'll let this sit for about 5 minutes and we'll spray it again. Okay, we're ready to go again. So give the rattle can a good shake again before you use it, just to make sure everything is nice and mixed up. And on this coat, I will make sure that I have all the rims and edges done. I'm not so worried about a thick coat inside the holes where the tube sockets are and things like that. So you can see I'm only lightly sprayed over the top of the chassis and the sides. So now I will focus a little bit more on that. So I don't want the coating to be too big in the actual holes itself. And give it a couple of blasts here. Okay, so here we go. And wait another 5 minutes, and we'll give it one more coat. Okay, another 5 minutes has gone past. Looks pretty good. Again, give it a good shake. This will be the last coat, so you want to make sure that it goes on pretty thick. And make sure that you get all the spots, no thin spots. And again, if you get any types of runs or anything like that, don't worry, it'll usually blend. Very forgiving paint. Again, this is the reason that they used this stuff way back when. because you can hose stuff down with it. And it works just fine. Okay, here we go. And that's it. So now, give it a little bit more heat. And I'll just let that sit. I think that's about enough. And let's see, which one will work good? I think this one here will work good. There we go. That'll be under the transformer. So now this will go into an oven, and I will show you what this looks like when it comes directly out of the oven in about 45 minutes. And that's the final result right out of the oven. Doesn't that look fantastic? That's near identical to the wrinkle coat they used way back when. And that's the result you get. So a couple of tricks. This was in the oven for about half hour. So the longer you leave these in the oven, they have more of a tendency to actually pull the wrinkle coat tighter. So you get, I guess you could say, tighter wrinkles. So if you time things and you keep your eye on it, like I did, I opened the oven a few times and looked inside, and this is about how I would like the wrinkle to look, because this is about as close to, say, a BC348 or the way an old factory piece of military equipment would have looked way back when. So if you want tighter wrinkles, just leave it in the oven for a little bit longer, I find. And this is all personal experience. And it's usually, you can set the somewhat look of your wrinkle coat. So very forgiving. Again, if you have any runs or you get any dirt in it or anything like that, usually turns out just like this. Just follow the steps, and you saw how I did in this video, and you'll end up with a result like this. So I'm extremely pleased with this paint. I'm not sponsored by this company at all, but I honestly have to say they make a really good product. Now that the chassis is painted, I have the transformer and the reactor to do. So very, very simple, same process. I'll remove both of the end bells just by removing these screws. And on this one, it's only two, and I can remove the end bells or caps on the transformer, and I'll put them in the garnet blaster and do the exact same process I did to the chassis. Now, one thing that I found that works very well with these tags is I'll cut a piece of Gorilla Tape and put a piece on here, and then with an X-Acto knife, cut it exactly around the tag, and it will protect the tag in the media blaster as I'm cleaning this up. Now, I would always suggest testing, your tape on a piece of steel to make sure that your media isn't aggressive, so aggressive that it goes right through the tape, but I've had very good luck with that. So a piece of Gorilla Tape usually saves these things, and it's a lot easier than drilling rivets out and taking it off, right? So just mask it off. Now I'll probably paint the cores of the transformer either a solid black or maybe even a silver. Silver would look really nice as well. They never put wrinkle coat on the cores, so I'll stay away from doing that. So I'll get all of the painting done and let all of the paint cure. And once that's done, let's start wiring it. Let's get this project done.
While I'm waiting for the paint to dry, I need to make an umbilical cord that runs from this radio receiver up to the power supply. And I need to make it long enough that I can either have the power supply beside the radio receiver, or if, say, I want to put a speaker or maybe even a pan adapter and a speaker on top of this radio receiver, I want to be able to, set the power supply on top. Because the tubes are exposed, you really can't put the power supply under anything. So if it needs to sit on top of all this, I need enough lead length to get there. So this will plug into the power supply, so it'll be a cord with a plug on the end of it, and I'm going to just hardwire that into this radio receiver. That way, this power supply will be permanent for this radio receiver, right? So I don't need these exposed pins on the back anymore, right? They are inside the case of the radio, so unless you're sticking your hand in there, you really can't come in contact with these. But still, why have these here if this connector is never going to be used again? So what I'll do is I will make a power cord, and I'm just going to actually make it right now just to patch it in here so that we can try the power supply. And then when we move on to the next step in the actual radio restoration itself, what we're going to do is wire that in here permanently, and I'll take you through that entire process. But of course, in order to actually try the power supply out, I need to make that cord first. So while the wrinkle coat is setting up, because it does take some time, I may as well do that. I'll go find a connector, and I have some wire here. I'll probably use black for the B-. I'll use red for the B+. I'll use brown for the AC switch lead. So this switch on the front here will turn the power supply on or off, which is actually a dual purpose thing, because the power supply won't run unless this receiver is plugged into it. So that's a good thing right there, right? So it's the power supply itself, you can't just turn it on standalone and then have it sit off to the side with no load being drawn on it, because of course all the current on the regulators and everything would go very high, because there's nothing pulling everything down, like the radio receiver isn't loading it. So this is a very good thing. It's actually kind of a safety feature to have that in here, and it works as the on-off switch as well. So I'll use brown for the AC leads, the AC switch leads. I'll use a light green colored wire for the filament, and I know I have some dark green wire somewhere. I have a piece of it here, so this is a dark green, and I'll use this for the filament common. So, and that basically the common is connected to the chassis, so it's basically the frame of the power supply connected to this. And quite some time later, I have an umbilical cord made. Now I just put zip ties on here just to hold this wire, because it's kind of unruly. If I take these off, it just kind of goes like this all over the place. So this just kind of holds it in place while I tack this into place here, so that we can try the power supply out. I'll probably in the final result put some era specific looking shielding over this wire, so that should make things look really nice. So I just put a whole bunch of zip ties just to stop this thing from being very unruly while we do the test. So I managed to bend these straight by working them out. So this is kind of still trying to curve a little bit, but not a big deal. So this here will run into the radio. So what I'll do is I'll just patch this into the radio for now. So in the end, when the power supply is all set up, this will just plug into it and we can try it out right away. So I may as well get that set up now. So as everything was mentioned, colors are what they do. So if we look here, so this is how it's set up. So pin 1 and pin 2 on the connector here, inside this little cup here, are connected like this. 1 and 2 are ground, so that's the actual chassis ground, and that's a filament ground there. And then the pin 8 and 7 are the heaters. So we have double connections on that, 2 pins for each one. They carry the most current, and it's good to have 2 connections for the ground to keep everything nice and safe. If one fails, you have the other, right? So we have pin 3, black is B-, and we have our 2 AC, this is the switch lead. So basically this just goes to a switch. So when this switch closes on the front here, which this switch is, so on either side, that would be on, that's off, and that's on. So we'll rewire this switch here, and I'll show you how to do that here. That will be the switch for this. So this will control a power supply, which is kind of nice. And then we have pin 6, which is the B+, and the B+ will just run in here. And that's really all we need to make this radio work with the power supply and this cord here. So I'll get this all wired in, still waiting for the paint to cure up. I want to give it a lot of time. This here, looks like a really simple thing, but this, took quite a bit of time to just find this. And I actually pulled this off the back of an old Sonar CB radio. And this was actually the plug on the back of the radio. And I found a cup which was used for an old eye tube. So the wires went in and this just snaps on. So I managed to get that together. And then, I cleaned out all the pins. So desoldered all the old wires, and then took my Heiko vacuum and then put it on the end of the pin, because you solder the end of the pin, vacuumed all the solder out of each pin. So they're all empty. And then stripped the new wires, put them in, and soldered them all in. So just, it looks so simple, but just the amount of time just doing this alone is Pretty crazy, but at least it's nice this way. So if I ever make another BC348 in this same fashion, I can just unplug this from the power supply and use that power supply on another BC348. Or who knows, maybe we'll make another power supply together down the road with a different type of regulation. Maybe we'll actually use past elements for that and compare it down the road too. Again, you know, in this Grand Receiver Restoration Series, you know, if there's enough interest in this and all that, you know, I'll keep going with all of this stuff, and we'll do some pretty fantastic things with these old receivers. They already receive very well, but I do have some tricks up my sleeve. The transformer and the reactor painted up quite nicely. So this is a lacquer paint from just an automotive store down the paint aisle. So it's something that you'd use to touch your car up. It's a gloss black paint. Usually come in a spray can, just a rattle can. And it usually takes quite a few coats. So if you spray it on and it looks like it's soaking in and it's not taking, don't get disheartened. Give it a whole bunch of coats, because what happens is a lot of times it soaks into the laminations. So a couple of coats and let it set. A lot of the times I'll spray a coat and then heat it quickly with a heat gun. Lacquer basically flashes off or you know, cures very, very fast. So it'll set, and then you can even sand it a little bit and then give it another quick coat and sand, and then you'll come out with a really nice finish like this. Now the laminations in the factory cores were never quite perfect. They were not like a modern transformer where they're perfectly in line. So sometimes you'll see staggered laminations. Absolutely fine. Don't worry about that, and don't try to correct it. Don't try to squish them together to correct it or anything like that, because you'll end up in a world of hurt. So these things have been, you know, in service since the 40s, you know, like this, and they're absolutely fine. So you don't want to really mess with the integrity of the core too incredibly much. So that worked very well. Another hint: after you're done, you want to work on this stuff, buy a nice or just grab a junk towel to work on. That way, if you drop a piece of solder or a screw on this or something like that, you can see where it is, so you don't drag your new paint over top of a sharp piece of metal and scratch up your paint. So I will be building that entire power supply on this, and it's actually on a nice soft foam pad as well. So it's kind of a double thing here. You'll notice on this, I still left the paint that I used to mask the windings up here. Even that's important. So this is a delicate surface masking tape. So not a normal masking tape, delicate surface, because you don't want to peel the paper off of this. So I believe it's a product by 3M. It's usually purple, and that's the kind of tape that you want to use. It's quite a bit different than regular masking tape, so even that's important, believe it or not. The paint on the end bells turned out very nice. Look at that, looks better than a factory finish. So worked out very, very nice. Right, a little bit of dust on here already. So it's very easy to get better than a factory finish on this, because you got to remember, these things are going down the line so fast at the factory. They're hosing this stuff on and it's getting baked. You spend a little bit of time with it, and you'll end up with, you know, results like that. So very, very easy to come up with good results with that paint. So now that all that's out of the way, you're wanting to put your brand new transformer back together, and you're thinking, oh, what's better than putting some brand new screws in this, right? So let's put some brand new screws in this. You know, these are a little longer for demonstration purposes here, right? So, you know, brand new screws. Put this through the core here. Oh, doesn't that look fantastic, right? You're thinking, oh, nice brand new shiny screws and everything, right? Oh, hold on a second. Did you notice what was on the old screws in the core of the transformer? No? Well, here, let me grab one of those screws and show you. You're probably thinking, hey, is that just a regular, you know, washer or something like that? Well, a lot of the times it'll trick you. You have to look closely. That is a cardboard washer. Why is that? Well, to stop the screw from shorting on the end bells. We're creating a partial turn here. Or depending on the way it shorts, we can even create a turn within itself. Depending on the transformer and where the screws are and everything, this can be a big, huge deal. So you're probably thinking, in a transformer like this, how much of a big deal is this? Well, it's actually quite a huge deal. So if we want to test this, because the windings are going like this, we will actually we'll short these two screws at the bottom. So we could mimic a short on the end bell. So tightening it down with a screw and a lock washer, short cutting through the paint, right? So if we wanted to do that, we could just mimic that by taking these two screws and doing that, right? So let's just take a current meter, and it's not, you know, directly in the center of the core or anything. It's off to the side here, but let's just hook a current meter up across this and see what happens, right? So now we're mimicking a short kind of through the end bells, and if it doesn't short, you know, this way, it can even short to the chassis. So if it's connected to one end bell and to the other end bell, when you screw this down to the chassis, the screws that cut into the feet here can short this through the chassis this way as well, right? So let's hook this up to some AC here through my isolation transformer and current limited variac supply. Again, I'm doing this for demonstration purposes to help you with your transformers. So let me do the dangerous stuff and hook this up like this. So again, this is for demonstration purposes. Don't follow this. So here we go. 28 milliamps. We've got going just through those screws right there. And it's a dead short, right? So we're pulling 28 milliamps. That's only this way. So what happens if we hook them up the other way and across this way? So we can end up with quite a bit of current here, you know, and depending on how we hook these things up, it might not even be a great connection. You got to remember that the core of the actual transformer itself is conductive as well, so the screw can short as it's going through the core to the actual core, and that's all waste current. This is all waste current. So if you're noticing transformer heating in one of your older radios, see, look at this, it's even climbing, right? So if you're noticing any type of transformer heating, it might not be because you think the transformer is rated for 110 or 115 or something like that. It might actually be the screws going through the core have shorted to the core. So if you're ever rebuilding these things, make sure you replace the washers at least on one side and put an insulation on the actual thread as it goes through the core so it doesn't short on the core itself. Right? So just say, so this is considered a turn this way. Here, I'll back this out a little bit. Hopefully you can still see this good. So this is considered a turn this way, but since we're going across the core now, we need to go crossways on the core to actually get any kind of current out of this. So let me find another long screw here to put through here. So we'll put another one through here like so, okay? And if we want to do that, so now we got to go to this one on this side, right? And let's take, so now we got to go crossways from top to bottom, right? Because we're not in line here. So I'll put this on the bottom and I'll put this one on the top. Now look at this, we're up to 44 milliamps and we haven't even gone to the other side yet. So what are we going to end up with, right? And then of course across the bottom again, and depending on the way you read this, depending on the way it shorts, you know, that's a lot of waste current. So you always have to keep that in mind. Make sure that you put those little, the washers can be cardboard or just something to insulate it, and something that, you know, with heat, that's going to deal with heat. And a lot of the times you'll find nylon ones in these transformers, or sometimes even Teflon, depending on the heat and how hot the transformer gets and of course the spec. But you'll find these washers on here that stop the screws from shorting. And again, it's very important to put you know, insulation. I use that high heat silicone tubing, silicone coated fibrous tubing across here when I slide it through the core, so that this doesn't actually short on the core. So what I'll do is I'll just shut this down here and I'll show you what I mean about shorting on the core. So move this all out of the way. Just think about that. It's just 3 screws, and we haven't even gone to the other screw, and we haven't hooked it up the other way yet, or anything like that, right? So this is stuff that really isn't taught anywhere, right? You know, transformer manufacturers know all about this, but this isn't taught. Like, I see so many ham radio operators and you know, people that are just rebuilding radios and trying to make good-looking transformers, just not paying any attention to that. So you get shorts in the M-bells, and you get, you know, shorts through the core, right? Because they have no insulation on here. So I'll take a regular just a DMM, and I'll show you, you know, the core is obviously conductive, right? So hook this off to the side here, and we'll just go from this core to that. Right, so it can short through the core all the way through, and that's all considered a loss. Those are all losses, and that might be the reason that your transformer is getting hot. Might not actually be. It's a very good chance that it, you know, could be that there's a shorted winding in the transformer, or, you know, that it was designed to operate at a little bit lower current, or a lower line voltage. But this a lot of the time happens, and even with transformers that haven't been tampered with, because over the years the washers break down from the thing being serviced, flipped upside down, and the transformer being pushed on, and or maybe somebody's removed the transformer, tightened the screws up really tight, and it's cut through those cardboard washers. There's all sorts of scenarios that cause that short in the core, and you get a heating transformer due to it. So there you go. Hope that helps you out. All right, so now what I'm going to do is get the M-bells back on these, and put brand new screws in this, make this look all really nice, probably use stainless even. And so it'll last a nice long time. And I'll get the power supply chassis here, put the power supply chassis on here, and we'll start putting the tubes on it and get everything put together here so we can try out that power supply. I'm looking forward to assembling this. It should be a lot of fun. All right, the chassis is ready to be assembled. The transformers went together very nicely. So I used acorn nuts on the other side, just as a decorative feature. And it has brand new nylon spacers on this side. So this is their intended use. So the old cardboard washers were getting pretty thin in some areas from being tightened down, so I didn't want to take a chance with those. So that will last the long term. So these are designed for high temperature applications, so really good there. And here is the small reactor, minus the dust and towel stuff. So acorn nuts as well. All right, it's coming together. Look at that. So it has the white ceramic tube sockets in there. It looks really nice. Very common for military gear to have ceramic tube sockets. So that looks really good. The jewel light worked out very nice. Everything mounted very well. So on the back side here, still don't have the line cord installed and the restraint up here yet. So, and I'll show you why here in a moment. The jack in the back for the umbilical cord. And on the bottom side, it's pretty much ready to wire. So there's the terminal tie strips in here and another one here. Now I don't know how many I'm going to need, but I put enough in so that I'm not going to have to drill holes in this chassis later on. So I want to stay away from any extra hole drilling at this point, obviously because it's been painted, right? So fuse holder installed. So basically what I'm doing here now is the lead length of the transformer indicates what tie strip is going to be used for what. So the shortest leads will go, to the closest tie strip here, and I will just work around that. Again, the transformer has some, pretty short leads, so that one may go there, and the shortest leads will go to the closest, and it'll look like the way it's supposed to be. It'll look like the leads were actually cut to fit there. So it's kind of a way around, shortcut transformer leads. Mount a terminal tie strip really close to it, and then feed all the leads into the terminal tie strip, and then just run fresh wires from that point. That way you also don't have to rewire the transformer. That saves quite a bit of time. There's quite a bit of lead length on the reactor leads here, so no problem there. Another terminal tie strip here, and it's pretty much ready for component installation. Yeah, number 47 lamp here, or I may use the smaller globe type so that the filament of the bulb is right in the center of the jewel light, so the jewel light is really bright. A lot of the times with the 47, sometimes the filament's a little higher up than the actual, the center here. So we'll see how that works. I have a whole bunch of bulbs, so that's not too big of a deal. So what I'll do is I'll start getting some of the wiring attached in here. When I get all the wiring completed, I'll explain exactly what I've done in here, and we'll take a look at the schematic. And I'll also use the regulator tubes, the jumpers in the regulator tubes, to disable the power supply. So if one of the shunt regulators is pulled out, the power supply will not function whatsoever. So I'll also use that in the design here. And here it is, all complete. So completely wired. I even took time to loom the wiring with era-specific material. This is actually looming material from way back when. It's basically like really big dental floss. So it's a wax-coated string that they used to use. In fact, I've got the roll right over here. Why don't I show you? This is what they used in the factories way back in the day. It looked just like this, and this is the stuff. So if you ever see a roll of this string anywhere and you're into restoring old radios, this is the stuff they use to do the looming. So I'll do a video in the future on how to loom wires. There's a special technique and a few tricks nowadays to make things just a little easier as well. So I loomed it all the way up and across on the top here, just to give it that look and keep everything nice and uniform. Wires are all color coded, so I know exactly where everything goes down the road. I haven't drawn a specific schematic for this yet. It's the same schematic that you did see. I've got a couple of scribbles on the other side here. I've moved everything off the bench because I've got to get the umbilical cord back on the BC348. So I've got a bunch of scribbles from the last time. So anyways, I've scribbled a bunch of these up. So it's basically this exact schematic. So this is inside the radio, right? And this is exactly what's in here. This was viewed in the last video or some variation of this. I scribbled a few of these things up. So the orange leads that you see match, these are orange cloth leads that come out here. They match that. So this is the plate leads for the rectifier tube. And the filament leads are yellow for the rectifier. And that leads out over here. And we have a red wire that's the B plus out. Over here, the green leads are the filament leads. The brown leads here are the switch leads. So when you plug this thing in, I even gave it an era-specific looking reproduction cord over here. So it has a cloth appearance to it. Looks really nice. So anyways, that runs through into here, and this runs into this main fuse over here. And the leads that are for this are brown, by the way. So leading back into that again, like the cord brown, these are brown. So the hot lead from the plug runs into this fuse first. It goes from the fuse up here to the jumpers in each one of these shunt regulators. So if you pull one of the regulators out, the whole thing will shut off. It won't allow you to use this, so the power supply voltage doesn't go high. So they give you those jumpers for that purpose. I talked about that in the previous video as well. So they're both in series, and that runs back out to this socket, and then from the socket into the transformer here. So this switch will be attached to these two brown leads on the umbilical cord when that gets wired into the receiver. The black lead here, black is the B minus. So the black leads that you see here are all attached to the B minus here. And the green leads are filament leads here. And there's a gray lead that runs up to the pilot lamp. So that's the hot lead for the pilot lamp. And just like that. So the darker lead, just like in the umbilical cord, is the ground, and then the lighter green is the hot lead for the filament circuit. Very straightforward. I even took time to loom the leads coming out of the choke. These were too short to loom, and no really point in looming them, so I just ran them off to the terminal tie strips. And I just left them the way they are. So I managed to get away with the lead length that came out of the transformer by putting this really close terminal tie strip here, and then running these ones over to this area, to this one that I added here for a little bit of, I guess you could say, ease of connection on this particular side. All of the filtering and the dropping is done here. These resistors are quite a ways up from these caps. Like, I can stick my finger in between the resistor and the caps, right? These get warm. I wouldn't say crazy hot. They get warm. And these are in series as well. So having these above these caps is absolutely fine. The caps are quite a ways away, and these are rated at 105 degrees C. So that's very, very hot. These, in service when these are running, I can actually rest my fingers on them. So that's not going to affect anything. Pilot lamp in the front. I believe this is number 55. Is it 50 or 55 I put in there? Let's see. Let's find out. It's 51. It's a GE 51 I put in there. And I talked about this earlier. The 47 sticks out about this far, right? And the filament is a little higher up, whereas in this one, the filament is very close to the bottom, and it's a lot closer to being in line with the actual jewel light. You'll notice that it's somewhat prismic, so even if it's a little on each side, it's fine, but the 47 is really off to the side. So I would imagine this particular socket was probably intended to have a 51 or something like that in it. So anyways, that's in there, so that lights up the jewel light. And that's pretty much it. Line cord restraint here, rubber grommets. And what else can I tell you about this? I think that's pretty much all. So that's what it looks like from the back, with the cord coming out. That really looks era specific. That turned out really nice, didn't it? And the bottom of the unit here, I've put some rubber feet on it. So they gave you these little areas here that you can center punch and then drill out, and I tapped these to 632 and just put some screws in the bottom. So I tried to keep all the screws on this, for aesthetic reasons, flat, like a blade type screw. And unfortunately, the box itself came with Phillips. So there's nothing I can do about those. I could probably find them down the road. They fit in here, so you really don't see them. They're on the bottom. So I kept everything on the bottom uniform. There's Phillips in here. And the box to hold the bottom on came with, little Phillips headed screws on the bottom. But everything else that you see on the top is all blade type screws, as you can see. So that turned out really quite nice, made quite a nice, made quite a nice appearance for it. And oh, of course, this thing here, so if I drop this on the base, like so, it has these nice, large rubber feet on the bottom, right? So it stands away up from the bench, so it really does have that old look. A lot of this older equipment had these really large feet on the bottom that protruded down from the bottom. So that worked out very, very well. So that'll look really nice sitting right beside the BC348. So now we just have to test this thing out. So let me take this off here. Another little trick with this, the reason this here is all felt marker. What you see in this area right here is all just felt marker. And the reason I did that is I didn't want to spray crinkle coat paint on this edge because of course it's pretty thick, right? And this isn't going to, screw down to the bottom of this. You can see this is nice and clean here, right? So that's one easy way of not seeing the edge is just basically get a felt marker and then just color in this area because, there's no thickness to it, right? And basically almost kind of dyes the metal. And then just put the thing on and then you don't see any kind of edge on here at all. So that works out very well. So just a couple of little tricks right there. Still have to work out the value of the fuse. Again, probably it'll be around an amp. This is 1.5. This is what I would call an absolute value. So something really major would have to go wrong with the transformer to take this out, or something would have had to be really major wrong with the wiring. So when we power this thing up, we'll find that out. I really don't think anything's going to go wrong in here, so it should be absolutely fine. So I guess now is the big reveal. I'll solder that umbilical cord onto the receiver, plug it in, and let's see if this thing works. And if so, then we can press on with the BC348 restoration. The power supply is now attached to the BC348 with the umbilical cord on the back. I've just tacked this into the BC348 just so we can try this thing out and see if the power supply works. So I've just left the bottom on. There's no screws in or anything like that, so it's just sitting on this bottom plate loosely here. So let's see what happens. I'll turn on the isolation transformer and current limited variac supply. And here we go, the moment of truth. It's looking good so far. Regulators have lit. Pilot light's on. That means we have 6.3 volts. And this means we have B+, so everything is looking good. If we look at the receiver, see the pilot lights are on in the actual receiver itself. So it's looking good. I'm very happy with that result. Look at that. Doesn't that look nice? That'll look excellent in a low lit radio room later on in the evening. All right, so nice orange glowing tube and a kind of a mauve purpley glowing tube, and then the filaments of this one, boy, this one's nice and warm already. So I'm very happy with the result. That absolutely looks fantastic, and that'll look so nice sitting beside the BC348 with these tall feet underneath it and sitting up on the bench, either beside or on top of a speaker, or maybe even on top of a pan adapter. Wouldn't that look neat? So I can say, just by telling this, I don't even really need to read any voltages because we did that all in the previous video. I can tell you that this thing is working just by the glow of the tubes, knowing that the pilot light's on and everything here. I know we're doing just fine. So very happy with the result. In the next video, we'll do all the testing as well, and we'll continue on with the BC348 project. And we'll also, I know some of you may be curious, but we'll verify the voltages on this. But it's pretty much a carbon copy of the last video, right? Just put on a very nice chassis and probably a lot quieter in the radio receiver as well. So again, I've mentioned this many times in many of my other videos, is whenever you take something like that, either on a breadboard or if you've built something dead bug style or point to point, just kind of out in the open, when you put them in a nice shielded chassis, a nice metal shielded chassis, and everything is nice and uniform, they work all that much better when they're all done. So anyways, there you go. Looking forward to getting on with the rest of this. Now, actually, you know what? Now that the power supply looks so good, I look at some of the scratches on the BC348. Maybe down the road, we'll have to take this faceplate off and re-wrinkle coat it as well and make this look brand spanking new. You can let me know what you think in the comments below. Building that power supply with you was a lot of fun. I hope you enjoyed this video as much as I enjoyed making and sharing it with you. If you are enjoying my videos, you can let me know by giving me a big thumbs up, and don't forget to subscribe and tap that bell symbol. That way you'll be notified as soon as I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and a very effective way, and gaining access to many of my personal electronic inventions and designs, and of course gaining access to another 200 videos, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on one of those links, it'll take you right there and you can check it out. All right, until next time, take care. Bye for now.